everybody. The purpose of this video is to walk you through a solution to problem 2.13.6 in collaborative statistics. It's a comparative question. You've got three different data sets. It involves schools running a mile. So you've got an elementary school, a junior high school, and a high school all running a mile. And the times. And the times for the elementary school on average are here, and the standard deviations for all three schools. So as you can see, the kids on average are getting faster as they get older, and the variances are changing slightly, but the idea predominantly is the kids are getting faster as they get older. And then you've got three kids, one elementary schooler, one junior higher, and one high schooler. And here are their, these are all in minutes, I'm sorry. These are all in minutes. As are all of the averages and standard deviations. And part A says, why is this kid here a better runner than this kid down here, even though this kid's got a slower mile time? Took this kid 8.5 minutes to run a mile. Took this kid 8 minutes to run a mile. Why is this kid considered a better runner? Okay, so a better runner. We're going to call this like the Michael Phelps, Mark Spitz comparison. We're going to say better runner would imply that on average, this kid's result is more impressive. Okay. Well, all you got to do is look at the z-scores. Look at the z-scores, or actually don't even look at the z-scores yet. We'll get into that momentarily. But look instead at what kind of z-score you would have. Okay. This kid right here with an 8.5 minute mile, that's below average for the junior high class. That means this kid right here is going to have a negative z-score because he's below average, which means he's left of average on the bell curve. We'll calculate it here momentarily. This kid with an 8 minute mile is actually above average on z-score as far as the z-score goes. So above average means he's actually slower on average than his class. Okay, so this kid here, because his mile time, or her mile time, this kid's mile time came in below average, negative z-score. This kid here, mile time above average, positive z-score. So a negative z-score versus a positive z-score implies, negative implies below average. That means on average, this kid, or I guess in specific, this kid's doing better than a higher percentage of his class in the mile. So as a percentile rank, he's in a lower percentile of time, which means he's actually beaten a higher percentage of his class overall in time for his mile. So, and this kid up here is also below average. And that's the next question, is let's bring the elementary school kid into it too, and let's see how they all do. So because all the data sets are different with different averages and standard deviations, let's standardize them across the board, okay? So let's look at a standardized measure. And that's what the z-score actually gives us, is a standardized measure. It allows us to convert each of these raw scores, which are on different scales. I mean, you've got three different scales, and put them all down into one scale. So for the elementary school kid, okay, there's z-score, the z-score for the elementary school kid. Take the raw score of 8 minutes, subtract off the average of 11 minutes, and divide by the standard deviation of 3 minutes. That's going to give you a -1 altogether. Units cancel. So he's got it, this kid's got a z-score of -1. Good so far. As far as the junior high kid, the z-score for that junior high kid, take their raw score of 8.5 minutes, subtract off the average of 9 minutes, and divide by the standard deviation of 2 minutes. So you're going to have a half over 2, a half a minute over 2, which is 1 minute over 4. So you've got and it's negative 0.25. So right away we can see this kid in elementary school is more impressive than the kid that was in middle school, because we've got a lower z-score. So this kid beat more kids as a percentage of his overall class. This kid beat more kids in his overall class. And we know that this kid in junior high did a better job than the high schooler from our discussion in question A, but we could probably do the high school in this space we have left over here. Okay, let's try to do it mentally without having to write the formula because I'm almost out of space on the board. Sorry. So for that z-score for the high schooler, take his raw score 8, subtract off the average of the class, which is 1. So that's 8 minus 1, which is a +1 over a standard deviation of 4, that's a 0.25 again. But it's a positive 0.25 versus a negative 0.25. So this kid exceeds a smaller percentage overall of the data set than this kid, and this kid exceeds a smaller data percentage of the data set than this kid. So I vote that the elementary kid's 8-minute mile over compared to the junior and high school kids is more impressive, makes him a more impressive runner than the junior high and or the high school kid. So there's my vote for who's the most impressive runner. Hope that helped.